Factor theorem from polynomials. Before understanding the statement of this, let us look into the division factor. For example, when we divide two numbers like a 15 divided by 3, that means 3 5s are 15, we get the remainder as 0. So this we call it as a remainder, this we call it as a quotient, and this is our divisor, and this is dividend. This is what we learned in our previous classes. That means what? So whenever you divide a big number with a small number, your remainder is 0 means it is a factor of that number. That means 15 has a factors of 3 and 5. How can we conclude that? Because our remainder is, since our remainder is 0, 3 and 5 becomes the factors of 15. Right? In the same way, here we are learning factor theorem for the polynomials. We all know that polynomial is a variable representation. So instead of doing direct numbers, here we are going to divide the different types of variable representation, algebraic representation, and we can remember this factor theorem. So let f of x be any polynomial of degree greater than or equal to 1. F of x be any polynomial. F of x is any polynomial, maybe cubic polynomial or quadratic polynomial, any polynomial of degree greater than or equal to 1, then x minus a is a factor of f of x if f of a is equal to 0. If something became a factor of that polynomial, then your remainder is 0. F of a is here your remainder. That will become the 0. Or else, if f of a became a 0, means if your remainder is 0, obviously x minus a is a factor of f of x. So your divisor will become a factor of the given polynomial. Let us look into this deeply. For example, we know the division fact, division algorithm. Dividend is equal to divisor times quotient plus remainder. See here, our dividend is a polynomial f of x, any polynomial like cubic or quadratic, and the divisor is x minus a here into quotient is q of x. We'll take the quotient as a q of x, and the remainder is f of x. Okay, so f of a is the remainder, right? So if it is like this, so when this x minus a will become the factor of the given polynomial, whenever your remainder is 0, that means f of x is equal to x minus a times q of x plus 0. Here the remainder will become the 0. That means f of x is equal to x minus a into q of x. Whenever your remainder is 0, then this x minus a will become the factor of the given polynomial. That is what given in the above statement. X minus a is a factor of the given polynomial. When it will become a polynomial, when it becomes a factor for the polynomial, if your remainder is 0, here our remainder is f of a. Here our remainder is f of a. So, for example, when you got to know your remainder is 0, that means you can conclude that the given number is a factor of the polynomial. So it is simple, I think. That's all here, very simple factor theorem.